All right, Jason, ready when you are.
Perfect, thank you. Okay, perfect. Well, hello everyone, and thanks for joining today's track presentation on water mitigation in data centers. And the subtitle here is Preparing for Natural Disasters and Climate Change. So just a quick introduction. My name is Jason Hood. I'm the Global Segment Manager for Roxtec, and my responsibility is data centers and advanced facilities in general. So what I'm going to share with you today is a little bit about what our experience has been in data centers, specifically when we talk about mitigating the effects of water and potentially causing downtime in data centers. What I'm going to show you today is based on a white paper that I've written, and it's actually available for download on this link. So this is essentially a summary of that white paper. And so today what I'm going to cover is downtime in data centers, the causes of downtime, looking at what are factors for site selection, what are the effects or what are the threats of water, the effects of climate change, and then water mitigation and protecting infrastructure. So first off, what is, how big of a deal is downtime? Well, if you look at some of the surveys that exist, going back to 2014 from the Uptime Institute, in that year, 25 to 46% of the respondents had experienced an outage. And surprisingly, 3 to 7% experienced an outage 5 times or more in that year. So if you look at the cost of data center downtime, referring to the Telecom Institute study from 2016, you can see that the average cost per downtime event is over $720,000. If you look more recently, the survey from Uptime Institute this year shows that from this year in 2020, we see that 40% of the respondents they had estimated the cost of their downtime to between $100,000 and $1 million. And even more surprisingly here, 16% over $1 million. So what does this mean? I mean, essentially you see that downtime happens, we know it happens, and when it does, it's really expensive. So what are the causes of downtime? Well, if most sources will cite the fact that most downtime is caused from human error. So in relation to this paper and what we're discussing today, we're not going to talk about human error, but we're going to look at some of the other factors that cause downtime. And if you look at the 2016 study from the Poneman Institute, you can see a variety of different causes of downtime. In relation to this paper, what we'll talk more about is the weather related. So even from 2016, you don't see a high percentage of downtime caused from weather related events. It is small, but it does happen. But this is the part that we're going to deal with today. If you look at this survey from Xenium, this was 2015. When you talk about weather related events, in this survey, 60% of the respondents said that their data centers were in low risk areas. And even 40% said that they were flood resistant. However, 50% of the respondents had experienced a disruption or downtime event due to seismic or flooding issues. And it doesn't take much research to see there are a lot of examples out there where hurricanes, heavy rainfall events, flooding has caused issues and caused downtime in data centers. Again, this isn't something that happens every single day, but it does happen. And if you look at the US, most of our natural disasters are severe storms and flooding. And according to the Department of Homeland Security, you see that 90% of the disasters in the US involve flooding. So again, flooding, while it's not the highest cause, the number one cause of downtime, it does cause issues in data centers. So what can you do? Site selection, obviously, if you can choose a site that is less prone to natural disasters, well, that's would be an obvious choice if you can. But natural disasters or risk factors such as these, that's not the only consideration when you look at a site, when you're trying to select a site. Other things that are taken into consideration is the actual fiber connectivity. What is the availability of that? Reliability and the cost of power is another big one. And also one of the trends you see now is going to renewable energy. So how is that a possibility as well based on the site? You also look at factors such as the labor pool or financial impact. So it's not completely just based on the one consideration of natural disasters. There are many factors that go into choosing the right site. So if you look at some of the standards, there are standards like this TIA 942, and it is encouraging that it at least recognizes when you get up to tier 3 and tier 4, you see that, for example, not within 100-year flood hazard area and greater than 300 feet from a 50-year flood hazard. So you see some designations and at least some considerations here that at the higher tier levels that these are factors to consider when you're looking at site selection. There's also this Bixy ASI002, and this is a good best practices guideline for data centers. So in relation to water specifically, what we're talking about now, you do start to see some terminology here that's related. You see the site should have a water table that is as low as possible. It should be below the utility ducts and below the lowest level of the building at a minimum. So you start to see terminology like this that takes into consideration what could, the threat of water and what this could mean for a data center and telecom equipment. So you do start to see some of this, but what we're going to discuss today is that there still is not a true standard when it comes to really sealing or hardening a data center against water or flooding. So if you look at these guidelines, again, most of them actually do recommend that fiber and power be put underground to reduce the risk of damage to overhead infrastructure. So we do see with some of our customers, we do see some of them currently even changing that methodology. So they're going from underground to go back to above ground. So that presents a risk. But even if you follow these guidelines and you put everything below ground, you're not risk-free. And that's the bottom line, is if you're below ground, you're increasing your chances of water infiltration into the distribution network, whether it's the fiber vaults of the outside plant, is it the actual building entrances with power, the utility vaults, the substation, all the power systems are at risk. So we know that water causes damage to electrical equipment. It is a hazard. So if you look at switchgear failure, which is referenced in this paper, not in this presentation, water is one of the known hazards to downtime and failure of switchgear. So a lot of times water will cause an immediate effect. You'll see the damage quickly, but sometimes it's latent. So sometimes it may not happen immediately, but down the road and long term, what you can see is damage to infrastructure due to water long term over the infrastructure and over the life of the facility. So water is a failure, is a threat to even the cable and the cable accessories. So one of the long-term effects can potentially be water treeing of the cable. So this is actually a degradation of the insulation material on the cable itself. This doesn't happen usually short term, but it can be caused by a lot of things, from the manufacturing impurities, defects. It could be the transportation, just pulling the cables itself, or heat in the system, or damaging, the degradation of the insulation being in service. So that can be a threat long term. There are things that you can do to minimize this. The effects of water treeing water trees could actually be abated by using tree-resistant cross-linked polyethylene cables or LC continuous armored cables. Those tend to provide the better long-term protection against the degradation of the insulation and ultimately downtime in the power system. So, but even if there's no degradation in the cable, if that's not your concern, a lot of times it's the actual accessories, the splices, the terminations, those can be the weakest link, and they need to be considered as well. What I want to show you now is a really nice paper that came out in 2018. And this is called Lights Out: Climate Change Risk to Internet Infrastructure. And in this paper, they talk a lot about what are the long-term effects from, what are the effects of climate change to critical, internet infrastructure. And a few of the things they discuss here are signal attenuation from water molecules embedded in microcracks that can affect the actual cable, corrosion to connectors, signal loss, fiber breakage due to freezing. This is a big one. We're working with a client right now who has discovered a lot of water infiltration into their fiber networks and outside plant. And while the water can cause issue, the immediate thing, short term, is even that the water freezes and it damages the fiber. So in these cases, we're being called in to help reduce that, really mitigate the water infiltration and reduce this threat. So that's a big one. And this paper really talks about this, and it talks about the sea level rise that's projected just less than 100 years from now, 1 to 6 feet of sea level rise. And by these projections, what this paper surmises is that there's over 4,000 miles of fiber that will be surrounded by water in 15 years. So a lot of this infrastructure will be submerged. The conduits will be submerged, they'll be filled with water, and the aging infrastructure is likely to be more vulnerable. So it's a very nice paper on the topic. It also highlights that in 2030, so 10 years from now, 771 POPs, 235 data centers, 53 landing stations, all of this infrastructure will be threatened by rising sea levels. And this chart actually shows you a list of some of the cities that they've laid out that would have, short term in the near future would have some effects from rising sea levels. So the obvious response here might be, okay, well, my data center is not close to the sea. Maybe I'm not so concerned about rising sea levels. Well, one of the things that climate change is actually causing is an increase in heavy downpours. And that's because warmer air holds more moisture. And if you look at this chart, this actually breaks out the increase in heavy rainfall events by region in the US. So there is no region that's hasn't seen an increase in heavy rainfall events. So a heavy rainfall event, what does that do? I mean, that can cause localized flooding. It can cause the fiber vaults outside plant to fill up with water. It can cause damage there. It can cause water ingress into the building and into power equipment. And it raises the water table level as well. So that can cause an issue with just localized heavy rainfall events. So if you look at the Uptime Institute survey from 2018, this isn't a huge number, but what you see is that in this survey, 14% of the respondents are taking climate change under consideration, and 19% are preparing for increased severe weather events. So that's a little bit encouraging. I think that you see the industry kind of moving towards some precautions, and it's not just limited to data centers, but this is something that a lot of cities and a lot of different municipalities and companies are taking into consideration for future designs. This is a survey actually came out from Fortune magazine last year. And the question was, what really scares world leaders? And you can see at the top of the list is extreme weather events. And even more recent, last year, what you see with the telecom companies here with AT&T, they're starting to look at this too. They're looking at the climate change models to see how is this going to impact our existing infrastructure, and what changes do we need to do in our methodologies. Do we put things above ground? Do we raise things overhead so many feet? How do we get out of flood zones? What are these precautions we need to take? So you're starting to see some movement and transition. So to summarize this, again, underground power and fiber infrastructure is vulnerable, even from heavy rain. Even if you're not next to the sea, it still represents a threat. And exterior power and fiber penetrations, that's an area where they are under threat, and there are solutions for that. And the threat of water is real. So what I'm going to share with you now, just some application, a little bit about real world of what we see here. But when there is no standard, again, I referenced that before, there is no standard on how to prevent water infiltration. And this is what we see as a company. You see pictures here, conduits and duct banks with nothing, no seal at all. If there is a problem after the fact, sometimes a site-specific application or solution might be to fill up the opening with some type of insulation or silicone or foam or whatever we can find. And these products are just not fit for purpose. They're not designed to hold back high pressure water levels, but they do show that there are problematic areas. Here's a couple of examples here in these pictures. This is some actual projects that we were involved with, where you can see on the left here, this is actually a substation. Underground penetrations for power and fiber, especially underground, they're going to be susceptible to the water table levels and water ingress into conduits and into substations. This is a real world problem that we get tasked with coming up with solutions on. Or you get the pull boxes themselves, the actual hand boxes, pulling cables, they fill up with water. And you can see even in both of these pictures, the customer has found that there's a problem, so they start shoving anything in the conduit they can to stop the water. And in this case, nothing. In this project we worked on, they actually were using cups, shirts, whatever they could find, rags, just whatever they could put in the conduits, because they don't know of a solution. And this is back to the original point. There's no standard for this. So again, just some additional application photos you can see here with some solutions of how we can actually keep the underground infrastructure dry. Just a few of the areas that are at risk, just to highlight here: transformer, generators, switchgear. These penetrations typically at the data center, at least the hyperscale side, this is outdoor equipment running the cables either above ground in trenches, going through the side of the building. This is a very common application. And again, I'm talking a lot about preventing water infiltration, but a lot of these applications also need to be fire rated. So when you choose a type of solution here for an exterior penetration, it's not only about water. A lot of times it's multiple demands. And that's very important when you're looking at what's to be used on the side of a building. Another possible area is rooftop application. So whether it's your HVAC, air handling units, or whatever, the penetration is going in to the top of the building, that's obviously could be a weakest link. That could be a weak link for you if you're not providing the right type of solution there. And design considerations, again, back to the lack of a standard. When you look at designing conduit seals or building seals or sealing the building envelope, one of the things that's lacking is that there is no requirement for constant water pressure or any type of pressure level or longevity of the seal itself. So these are very important things. Another risk factor is rodents and vermin. This is a big problem. We see a lot in equipment. Rats and rodents cause a lot of damage to equipment. And so it's important to think about that when you use a seal, to make sure that you're also protecting against rodents, that the product's going to withstand, keep out rodents and not be, something that the rodents love to chew on and tear through like other products. So just another consideration. So in summary, again, downtime, it happens, it's expensive. Water and weather related events are the causes. Flooding is a threat to data centers, and climate change is intensifying storms and heavy rain. So we do see that happening. And even if you're not in a coastal area, there's still a threat of water. So again, we work with a lot of customers that are not in coastal areas at all, but they're seeing high water table levels causing ingress of water into substations and again, outside plant, and causing downtime. So So what is the call to action? Again, just to reiterate this, there is no standard for building envelope. How do you seal the building envelope? How do you seal underground fiber power distribution? At this point, this is usually left up to an engineering firm designing the solution or recommending it to the operator. We're finding that a lot of times it's the operators that are having the problems, and then they come to us after it's reached a critical point. So our stance here is that we need to look at what is the standard. It's not enough just to say seal the conduit, seal the vault. You have to think about where are the critical areas that we need to protect, and what are the requirements? What's the protection level? What are the hazards we want to protect against? And what's the performance level? Again, a lot of these products that are used will not hold back constant water pressure. So what my stance here is that we need to have a collaboration to create an industry standard for data centers really to protect against water infiltration. So with that being said, I think I'm right at the time here. Are there any questions?
Hey, Jason, haven't seen any questions come through the chat.
Okay.
I will say that if anyone is listening and wants to ask a question, feel free to jump on the Zoom. You can do that by clicking the Join Now button below the video player, and you can ask Jason a question directly.
So I think if there's no questions, Michael, the slides are available to download, correct?
Yes. So folks, you should be able to download these slides by scrolling down just below the chat box on the FM Virtual platform, and you can download those directly right there. As a matter of fact, Jason, it's a great point. I'm going to go ahead and share my screen, and I'll just show folks where they can access these slides and any others. So everyone here, you have your video player. Scroll down to additional media and links and download the slides that Jason just presented. And I think that answers Gloria's question of how to get slides. To access slides for any other previous sessions, you'll have to go down to the schedule and click into a session that resets all the additional material and links. So you can access those slides. And Jason, with that being said, thank you so much for the presentation. Folks, if you do have any questions for Jason, you're just being a little bit shy right now. I'm sure he'll be around for